Special quadrilaterals. So a quadrilateral is a four-sided shape. So we're going to have a look at four different quadrilaterals and their properties. So let's start off with a square. So it has four equal sides. So those little lines there mean that the lengths are all the same. Its opposite sides are parallel. So those little arrows there mean that these two lines are parallel. They'll never meet. They're going in the same direction. And these two lines are also parallel. They'll never meet. They're going in the same direction. All angles are the same size. So we have 90 degrees in each corner. And 90 multiplied by 4 is 360. And the angles in any quadrilateral add up to 360 degrees. And then the diagonals. So a diagonal is a line that goes through each corner of the shape. So square has two diagonals. And the diagonals bisect each other, which means cut in half. And there are 90-degree angles in the center. So if we look at this a little bit closer. So the diagonals, they bisect each other, which means they cut them in half. So this diagonal cuts the other one in half, which means that this line is the same length as this line, which is the same length as this line, which is the same length as this line. That's why they have those little smaller lines inside them. So for example, if this is 5 centimeters, then this is 5 centimeters, this is 5 centimeters, and this is 5 centimeters. And we have 90-degree angles in the center. So four 90-degree angles where the diagonals bisect each other. So now let's have a look at a rectangle. So its opposite sides are equal in length. So those little lines there mean equal length. So this side is equal to this side in length. And this side is equal to this side in length. So that's why they have one single little line there and there, representing that they are equal in length, and then two little lines on both of those sides, representing that they are equal in length. Their opposite sides are parallel, just like with a square. So this side is parallel to this side. They're both going in the same direction. And this side is parallel to this side. All angles are the same, so 90 degrees in each corner. And again, 90 degrees multiplied by 4 is 360 degrees. So the angles in a quadrilateral always add up to 360 degrees. And the diagonals bisect each other. So let's have a little closer look at this. So in a rectangle, the diagonals bisect each other. So that means cut it in half. So again, if this is 5 centimeters, then this is 5 centimeters, this is 5 centimeters, and this is 5 centimeters, etc. So those little lines there represent equal length. So then we have a parallelogram. So opposite sides are equal in a parallelogram. So that line is the same length as that line there. And that length is the same length as that as well. So the sides that are parallel are equal in length. So opposite sides are equal in length. And then opposite sides are also parallel. So this side is parallel to this side. They're going in the same direction. And this side is parallel to this side. They're also going in the same direction. Opposite angles are equal in parallelograms. Let's look at this a little bit closer. So this angle is opposite to this angle. So they are equal. So for example, if that was 50 degrees, then that would also be 50 degrees. And likewise on the other side, this angle is equal to this angle because they're opposite each other. So if that was, let's say, 100 degrees, that would also be 100 degrees. Also, what's not mentioned here is that co-interior angles or supplementary angles of a parallelogram add up to 180 degrees. So for example, these two angles added together should add up to 180 degrees, and these two angles added together as well should add up to 180 degrees. Likewise, these two angles here should add up to 180 degrees, and these two angles here should add up to 180 degrees. And then the diagonals. Well, the diagonals bisect each other, which means they cut each other in half. So, for example, this length is going to be the same as this length. So again, if that's 5 centimeters, that's 5 centimeters. However, these lengths will not be the same as these ones. So if this is 10 centimeters, then this is also 10 centimeters. But it does not mean that they are all the exact same, as was the case with the other shapes so far. So if this is 5 centimeters, then this is also 5 centimeters, but this is not, and this is not. But if this is 10 centimeters, then this is also 10 centimeters, but this is not, and this is not. So these two are equal, and these two are equal. And finally, we have a rhombus. So it has 4 equal sides. It's a parallelogram, but all the sides are the same. So this length is the same as this length, is the same as this length, is the same as this length. So if that's 10 centimeters, that's 10 centimeters, that's 10 centimeters, and that's 10 centimeters. Just like with a parallelogram, opposite sides are equal. So this length is going in the same direction as this length, and this side is going in the same direction as this side. Again, as with the parallelogram, opposite sides are equal. So this angle is equal to this angle, and this angle is equal to this angle. Now let's look closely at our diagonals. So the diagonals bisect each other, and the angle of 90 degrees is formed. So there's a lot that needs to be learned for a rhombus. So the diagonals bisect each other, so this length here is the same as this length here. So if that's 5 centimeters, then this is also 5 centimeters. However, these are not the same length as these two. So if this is 10 centimeters, then this is also 10 centimeters, but these two are not, etc. So we have right angles in the center, 4 right angles, 90 degrees, 90 degrees, 90 degrees, 90 degrees. So really we should have another little L shape drawn in there and there. So 90 plus 90 plus 90 plus 90 is 360. Now also, the angles are bisected by the diagonals. So, for example, this angle here is equal to this angle here. And we also know that opposite angles are equal. So this angle here is going to also be equal to this angle. So if this was 30 degrees, this would be 30 degrees, this would be 30 degrees, and this would be 30 degrees as well. And the same is true on the other side. If this was 40 degrees, then this would be 40 degrees, this would be 40 degrees, and this would also be 40 degrees. Also, we can use one of our rules that alternate angles are equal. So this angle is alternate to this angle, so they have to be equal. And this angle is alternate to this angle, so they have to be equal. Then this angle is alternate to this angle, so they have to be equal. And this angle is alternate to this angle, so they have to be equal. So there's a lot to be learned for the rhombus. So that's 4 quadrilaterals that we're having a look at. There is also a trapezium, but I'll look at that in a later video. And now we're going to have a look at a few examples that we can work through. But it is important that all of this information is learned off by heart. This will not be given to you in the formula tables. In the following parallelogram, find the length of AB. So this is AB over here. And AB is opposite to CD, so they must be equal length. So if CD is 15, then AB must also be 15. So the length of AB is equal to 15 because it is opposite to CD. So if this is 15, this is also 15. Part 2, find the length of XC. So XC is this line here. Well, we know that the diagonals of a parallelogram bisect each other. So that means this length must be the same as this length. So if this is 14.75, then this is also 14.75. So the length of XC is 14.75 because the diagonals of a parallelogram bisect each other, cut them in half. Bisect means to cut in half. Part 3, find the length of AC. So from A to C, well, we know from here to here is 14.75, and from here to here is 14.75. So add them together, or else multiply one of them by 2, and we'll get our answer. So AC is twice the length of AX. So the length of AC is going to be 2 times 14.75, or else 14.75 plus 14.75, which gives us 29.5. So AC is 29.5. We weren't asked anything else, but if we had been asked what the length of AD is, it's going to be 18 because BC is 18. And if, for example, BX was 10, then XD would also be 10, but we weren't asked anything else. In the following parallelogram, find the length of angle 1. So this is angle 1 here, and we can see that it is opposite 70 degrees, and opposite angles in a parallelogram are equal, so angle 1 must be 70 degrees. So angle 1 is equal to 70 degrees, opposite angles in a parallelogram are equal. Now we want to find angle 2. So this is angle 2 here, and angle 2 is alternate to angle 80, which means they must be equal. So we can see that it forms a Z shape. So angle 2 is alternate to angle 80, which means they are equal. So angle 2 is 80 degrees. So angle 2 is 80 degrees, alternate angles are equal. Now we want to find angle 3, which is this angle down here. Well, we can see that angle 3 and 70 and 80 all form a triangle, and the angles in a triangle add up to 180 degrees. So angle 1 plus angle 2 plus angle 3 will equal to 180 degrees, because the sum of the angles in a triangle equal 180 degrees. So 70 degrees plus 80 degrees plus angle 3 will equal 180 degrees. So angle 3 will be 180 degrees minus 70 minus 80. So 180 minus 70 minus 80 leaves us with 30 degrees. So angle 3 is going to be 30 degrees. Now we weren't asked to find anything else, but if we were asked to find this other angle here, it would also be 30, because angle 3 and this angle up here are alternate to each other, so they're equal. In the following rhombus, find the length of angle A. So angle A is in here, and because it's a rhombus, we know that this must be 90 degrees. So angle A is equal to 90 degrees because right angles at a point of diagonals intersection. So we have 90 degrees, 90 degrees, 90 degrees, and 90 degrees. Part 2, find angle B. So angle B is over here. Well, angle B is going to be alternate to 40 degrees because we can see it forms a Z shape. So 40 degrees and angle B are alternate to each other, so they're equal. So angle B is going to be 40 degrees. So angle B is 40 degrees because it's an alternate angle. Then we want to find angle C, which is this one here. Well, again, this is a rhombus, and we know that the diagonals of a rhombus bisect the angles. So this angle here has been cut in half by the diagonal. So if this is 40, this must also be 40. So angle C is going to be 40 degrees. So angle C is 40 degrees, diagonals in a rhombus bisect the angle, cut it in half, bisect. So we weren't asked for this angle up here, but that would also be 40 degrees. 40 and 40, 40 and 40. Then we want to find angle D. So this is angle D here. Well, we know that angle D and 90 and 40 all form a triangle. And we know that the angles in a triangle add up to 180 degrees. So angle D plus 40 degrees plus angle A, which is 90 degrees, equal 180. So angle D plus 40 degrees plus 90 degrees equals 180. So angle D is going to be 180 minus 90 minus 40, which will leave us with 50 degrees. So angle D is going to be 50 degrees. And again, we weren't asked to find anything else, but this angle here would also be 50 degrees. And these angles over here would be 50 degrees and 50 degrees as well.